Alright guys, so today in class you guys had mentioned that you wanted to do some review on systems of linear equations, so here we are. What I've got is just a real light review at the beginning, and then I pulled a couple questions from your quiz on the 4th that I think some of you may have struggled with, so we'll take a look at those and solve those. And so from what we remember about linear equations, right, is that they're a set of equations that are solved collectively together. They have the same answer. They share the same answers. And the basic linear system is composed of two linear equations with two variables. So remember that linear equations are equations that represent straight lines when graphed. So essentially, when we solve a system, we're solving for the point where those two linear lines, these are our two equations, intersect. That's the solution. And that's what we're solving for. And remember that there's two main ways in which we can solve systems of equations. The first way being the substitution method, and the second way being the elimination method. But first, let's take a look at the substitution method. And we're given this system of equations. 2x minus y equals 0, and 5x minus 2y equals 3. And what we want to do first, for the substitution method, is put one of these equations in terms as a form of one variable in terms of the other. What I mean by that is I wanted to either say x equals something or y equals something. And so I see that in this first equation, 2x minus y equals 0, this is relatively easy because we can just add a y to each side and we're left with y equals 2x. And now that we know that y equals 2x, we can take what we know y is, substitute it into our second equation, and then we'll get 5x minus 4x equals 3. Combining like terms, we see that x equals 3. Now that we know what x equals, we can take this value and substitute it back into the initial equation. 2x minus y equals 0. So 6 minus y equals 0, so y equals 6. And that's our answer. X equals 3 and y equals 6. And then we should also check it with the other equation to make sure that it works. So with x equals 3, 5 times 3 minus 2 times 6 should equal 3. So what's 5 times 3? That's 15. Minus 2 times 6 is 12. Does that equal 3? It most certainly does. So our answer of x equals 3 and y equals 6 are correct. Okay, now let's take a look at the elimination method. So the elimination method is, I'm going to be frank, is not my preferred, but it may be yours. And so what we do for problems that are in an elimination method form is we just simply add them together if it looks like they cancel out. And if they don't, say for example there was a 2 here, we multiply this by a scalar 2, and then we could add them together and cancel them out. But we don't need to do that here because they have the same coefficient. So doing our addition, x plus 2x, that's 3x. Y minus y, that's 0. And then 12 minus 6, that should equal 6. So now we know that 3x equals 6, and if we divide each side by 3, we can see that x equals 2. Now that we know that what x equals, we take x back to one of our original equations. 2 plus y equals 12, so y must equal 10. And so before we can tell if these are right, we must substitute these values into the other equation and make sure they hold. So 2 times x equals 2 minus y equals 10 should equal negative 6. So does 4 minus 10 equal negative 6? It does. So our answer is x equals 2, y equals 10. Okay, now some of you guys in class had mentioned you wanted to take a look at problems that involved 3 sets of linear equations. So I pulled this one from your quiz on the 4th. This was number 4, the extra credit problem. And we're going to look at how to solve this. So first we can look at this and we can determine which method to use. It will be really cumbersome to use the substitution method, the elimination method. So I recommend using the substitution method. So first I'm going to look at this equation and make it, since z is here by itself, I'm going to make it z in terms of x and y. So I add a z and I add a 7, and I get that z equals 4x plus 3y plus 7. Next, we want to take what we know z is, substitute it into a different one of our equations. I'm going to erase this so it looks a little cleaner. And we want to solve for y in terms of x. So we'll take the second equation, 3x minus 2y minus what we know z is. And then we know that this equals negative 9. So I'm going to distribute this, negative 1, 3x minus 2y minus 4x minus 3y minus 7, all equals negative 9. And I'm going to combine my like terms. So just so we can see them easier, here's an x, here's an x. Here's a y, here's a y. Here's a constant, here's a constant. Okay, now we're going to combine like terms. So 3x minus 4x, that just gives us a negative x. Negative 2y minus 3y, that'll give us a negative 5y. And then I'm going to add 9 over. So negative 7 plus 9 should be a positive 2. And then this equals 0 because I added the 9 to the other side. So we almost have y alone. I'm going to add 5y. I'm going to get negative x plus 2 equals 5y. And now I'm going to divide by 5 on either side. So we know that y equals negative x over 5 plus 2 over 5. Now the final step here is a little involved. We know what y is in terms of x. We know what z is in terms of x and y. And then we have this final equation. So I'm going to take it. I'm going to take my 2x plus 5 times what our y equals, negative x over 5, plus 2/5. And then I'm going to add what our z equals, which is 4x plus 3y plus 7. But we know what y equals, so we'll have 2x plus, we'll distribute this 5, and we'll get a negative x, and then we'll get a 2, plus 4x plus 3 times negative x fifths, plus 2/5, all plus 7, and this equals negative 3. Okay, and now we solve. We combine like terms, So let's find our x terms, x term, x term. Here's an x term. I guess I should distribute that first. I'm ahead one step, my bad. So 2x minus x plus 2 plus 4x plus minus 3x over 5 plus 2 over 5 plus 7 equals negative 3. So we combine like terms. Here's our x term. Here's an x term. Here's an x term. Here's an x term. And then we're looking for constants now. Constant, 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 constant. So let's combine on the left-hand side of the equal sign. So 2x minus x is just an x plus 4x. That gives us 5x. Then we still have this minus 3x over 5, And then we shall see that 2 plus 7 is 9. And then we have to add 2/5 to that. 9 plus. And this should be a 6/5 because we distributed that 3. So this should be a 6/5. 9 plus 6 over 5 equals negative 3. Okay. Now I'm going to subtract this to that side. So 5x minus 3x over 5 equals negative 12 minus 6 over 5. And then 5x minus, now we want to combine like terms, right? Or we want to find a common denominator so we can combine like terms. So how many fifths is 5? That'd be 25/5 fifths x. I wrote a 2, that should be a 5. Since they have the same denominator now, we can put them both in the numerator. Equals, how many fifths is negative 12? That'd be negative 60 fifths minus 6 fifths. So we see that 22x over 5 equals negative 66 over 5. The first thing I'm going to do is multiply by 5 on each side. So 22x equals negative 66. And then we divide by 22. And finally, we see that x is negative. Now that we know what x is, we can solve for y pretty easily, right? Because we know what y is in terms of x. So let's take this. And then let's substitute in x equals negative 3 to this equation. And then we will find the value of y. So y equals, this will be negative 3 over 5 plus 2 over 5. So y equals 3 fifths plus 2 fifths, which is 5 fifths. So y equals 1. All right, now that we know what x and what y is, we can take what we found z to be and solve for z. So here's our formula for z. We'll bring it down. Okay, and then we want to substitute in x equals negative 3, y equals 1 to this equation to solve for z. So z equals 4 times negative 3 plus 3 times 1 plus 7. So z equals negative 12 plus 3 plus 7, negative 12 plus 10. So z equals negative 2. All right, now that we know what x is, we know what y is, and we know what z is, we should check this to make sure that it works. So let's take this third linear equation and we'll check. And you would check for all three, but I can leave that as an exercise for you on your own. So 2 times negative 3 plus 5 times 1 minus 2, because z is negative 2. This should all equal negative 3. So does negative 6 plus 5 minus 2 equal negative 3? What does that mean? Negative 1 minus negative 2. That does in fact equal negative 3. So these are our solutions. So last up, you guys were asking for some work with word problems. So we could take a look at the word problem from your quiz again. This was problem number 6, if I remember correctly. So this problem says, Ryan spent $84.05 to purchase 13 flowers. He bought 2 different types of flowers. Rhododendron. Oh no. Excuse my spelling. Cost $6.85 each. And again, another word I'm going to struggle to spell. Chrysanthemums. Cost $5.85 each. So, part 1 asks, if R is the rhododendron, so, okay, we can remember R is the rhododendron, and then C is the chrysanthemums. Write an equation in terms of R and C describing the total number of flowers he bought. So, we remember that he purchased 13 total. So right off the bat, we know that 13 is going to equal something because he bought 13 total. And we know that there are only 2 types of flowers, right? The rhododendron and the chrysanthemums. So it should just be 13 equals R plus C, and that's our equation. Because the total number of rhododendrons he bought plus the total number of chrysanthemums should equal the total number of flowers he bought, because he only bought those two kind. So this is the answer to part A. All right, now part B. Part B asks, write an equation in terms of R and C describing the total amount spent in dollars. So we know in total he spent $84.05. So that cost is derived from how many rhododendron he bought and how many chrysanthemums he bought, and also the price for each. So if rhododendron cost $6.85 each, this is how we find our total cost for those. And then our total cost for the chrysanthemums will be C times their price, $5.85. And this is the answer to part B, because we'll get the cost for each type of flower, and we add that together. That's his sum cost of $84.05. Now, this says to use the elimination method, solve for the value of R. So we have our two equations, right? R plus C equals 13, and we have 6.85 R plus 5.85 C equals 84.05. Okay, so what can we do? What scalar can we multiply to this first equation to ensure that we're only left with an R? So we should look for negative 585, because that would cancel out the C, this top C, with this bottom C. So let's multiply this whole thing by negative 5.85. And then that'll look like minus 5.85 R plus, minus rather, 5.85 C equals, then 13 times 5.85, if you give me 1 second with the calculator, will equal 76.05, and remember that's negative because we're multiplying by a negative number. Okay, and then we're adding this to 6.85 R and 5.85 C and 84.05. Adding this, and we want to see what we're left with. Okay, so negative 5.85 plus 6.85, well, that just gives us 1, right? So 1 times R is what we're left with. And then we rig this so that these will cancel out. So this will be plus a 0. And then 84, there's negative 76.05 plus 84.05. That's the same as 84.05 minus 76.05. And that should be a difference of 8. So we're left with here, essentially, that R just equals 8. And that's the answer to part C. And then now we must solve for the number of chrysanthemums, which we will take this R value and we can substitute it into either of our equations. R plus C equals 13, for example, and R is 8. So 8 plus C must equal 13. So C must equal 5. And then for an exercise for you guys, check to make sure that R equals 8 and C equals 5 satisfy this second equation. Okay, that should conclude everything I have for you today. Thank you guys for watching. Have a good day.